Good afternoon, my YouTube viewers. Crystal here. This is the afternoon of Thursday, 17 September 2020. What I wanted to do is I wanted to give you the solution to the Analytics by Keras upsell competition that's going on this week, which is why I've given you the date so you know the week that it's going on. It's only about 3 days left till the competition ends, and I don't think that I'm going to formally enter the competition because you have to submit the code, which I'm going to show you right now so you know I have the code. But I think you also have to submit a PDF file of something like that. And my score isn't high enough to win the competition. So I think, well, if my score isn't high enough to win the competition, there's not really a whole lot of point in me making a PDF file with other information that they're asking for. But what I wanted to do is I wanted to go ahead and give you my solution. And I used Keras this time. You'll notice the video that I made yesterday, I had a solution, and it was on XGB classifier. Well, the audio wasn't turned on, so the only thing that you're getting is the video and not the audio. But I decided to go ahead and leave the video up there because you've still got the code. So if somebody wants to look at the code, they can look at the code. But I decided, well, since that video didn't work out correctly, I decided I was going to go ahead and do the solution using Keras. Because the thing is that when you enter a competition or when you do a practice problem, you have to try several different models to see which model works the best. And so I decided to give Keras a try. The thing about the XGB classifier, I got a 65% accuracy, which I was okay about considering the fact that the highest score in this competition is not even 85%. But this solution that I'm giving you right now is about 78%. And I got up in the middle of the night and worked on it. And I had to experiment a lot with different configurations. I started out getting a little tiny bit of the code from a publication. But what happens with these people who write for these publications? Well, they just want to be paid. So they submit this article with the code to the publication, but it doesn't work. And I found that out happened a lot, that I would borrow code that I got from a publication to try to help me with my programming, and the code wouldn't work. And I find it quite annoying, really, because these people should make sure that the code works before they submit it to the publication to be published. But the simple fact of the matter is that they just want to be paid for their work. But it's not really very good work if the code doesn't work. That's one thing I will say. So without further ado, I'll go ahead and give you the solution to the Analytics VidHaya cross-sell competition that's being held this week, September 2020. It's on 16 September 2020. It's only got like 3 days left until the competition ends. So the first thing I did was I imported all my files, and you'll see I had quite a few files. Some of the files I didn't need, but I went ahead, and as I was experimenting, I would need to have these libraries. So I went ahead and kept the libraries in there. And then I loaded up my train file, test file, and sample submission file. The next thing I did was I set up the code for ordinal encoder, label encoder, and standard scalar. I ended up not using the ordinal encoder because, try as I might, I couldn't get it to work. So I'm going to have to experiment some more on ordinal encoder and find out what happened. So you can see the train file. You see we have a combination of text and numbers, and the very last column is response. So that's your target column. The test file has the same format as the train file, except for the fact that it does not have a response column. So that's what we have to calculate. We have to calculate the response in the test file. Looking at the sample submission, this is the format that Analytics Vidhya wants us to submit our work, which I did that. I submitted my work and then I experimented with several different formats until I came up with about a 78% accuracy, which I think is not bad considering the fact that the highest accuracy was not even 85%. So I'm only 7% lower than the highest accuracy, but I just think that when they award the prizes, they're going to award the prizes to the people with the highest accuracy. So I'm not going to, enter it formally by submitting PDF files and things like that. I can submit the code because I've got the code in front of me. I'm showing it to you, but I would have to create a PDF file with some other information in it. And I don't want to do that if I'm not going to win. And there's no possibility of me winning. So we've got information on the test file, and the test file is the same structure as the train file, except for the fact that there's no response column. Check to see if there were any null characters in the train file, and there are no null characters. Check to see if there were any null characters in the test file, and there were no null characters. So that was one good thing. I did not have to deal with any null characters. All of the characters in both of the files had placeholders in them, so I did not have to replace the null characters with other characters. I made a plot of the SNS file, and you can see that there were only two outcomes. One outcome was a 0, and another outcome was a 1. And you can see that most of the responses were 0. What we did was we tested the gender, and the gender was male and female. So what we did with that was we did a get dummies, and because we did get dummies, instead of male and female, we only had 0 and 1, and the get dummies was only one. Was only one column. It wasn't two, because there was only one variable, or there were two variables, but you could fit both of those variables into one column. And so what we had to do was, because the gender column had originally been a string or an object, we had to convert it to an integer. So you can see here that I converted it to an integer. Now we've got a violin chart here of the ages, and so you can see that the majority of the people who had insurance were young. They were like between 20 and 30. And so what I did was I did a group by on the ages, and I plotted the ages out in a chart so you can see the chart of all of the ages. And as you can see, it confirms that most of the people who have insurance were young. They were between 18 and 25. Then I created some bins, and I put the ages into a group of child, young adult, middle-aged, and pensioner. So here you see the age range is a child, young adult, middle-aged, and pensioner, but there weren't any children who had insurance. And then what we did was we used a label encoder, so all of the columns except for child were assigned a number. Check to see if there were any is null characters. It's always very important to check to see if you have any is null characters when you're making bins, because it's really easy to make a mistake and end up with some null characters. So that's one way that you can check your work. So we checked our region code, and I don't know very much about the region code, so I could not sort the region code out. So I could have the region code as it was, but I decided to go ahead and label and code the region code as well. So we labeled the region code, and we had 53 regions. We did a group on the vehicle age, and there were 3 categories that the vehicle could be. It could be 1 to 2 years, less than 1 year, and greater than 2 years. So what I did was I put it in a label encoder, and the label encoder gave the labels numeric values of 0, 1, and 2. So 1 to 2 years was 0, less than 1 year was 1, and over 2 years was 2. Then what we did was we converted the vehicle age column to an integer because it had previously been a float. No, it had been an object. The next thing we do is we want to see if there's any vehicle damage. And so you have a yes or a no. And so that's two variables, or two categories. And so what we did was, I did it, since it was only 2 categories, I used the get dummies command. And so yes was a 0, and no was the 1. So you had 45,728 zeros. So that means that was the number of cars that had damage to them. Then what we did was we converted the vehicle damage to an integer because it had previously been an object. And the computer wants to see numbers. It doesn't want to see objects. So anytime you have an object, you have to convert that to a numeric value before the computer can do anything with it. So now we've tested the premiums. I didn't know very much about the premiums, but what I did was I created some bins of low, medium, and high. And so 0 to 10,000 pounds was low, 10,000 pounds to 100,000 pounds was medium, and 100,000 pounds to 550,000 was high. I didn't even know that people paid premiums that high. And so we made an extra column called premium range, and we dropped the annual premium column, and we put the low, medium, and high in the premium range column. And then what we did after we did that, we label encoded premium range. So instead of low, medium, and high, we had 0, 1, and 2 to label encoded. And we also did a group by. And then because we created these bins, what we wanted to do is we wanted to see if we had any null characters. And no, we did not have any null characters. The next thing we did was we checked on the policy sales channel, and that was anonymized, and I don't know very much about it. So and I put the policy sales channel in a label encoder. So all of the anonymized numbers were label encoded. The next thing we had was we had something called vintage, and what that is that was how long the client or the customer had been with the company. So I created some more bins. If they were 0 to 90 days, they were new. 90 days to 180 days, they were medium. And 180 days to 270 plus, I just labeled it old. And we created another column called vintage range, and we dropped vintage. And then what we did was we label encoded the vintage. We label encoded the vintage range. And so now instead of lots and lots of digits, we have just 3 numeric categories that it can fall in. And the next thing I did, because I created bins, wanted to test to see if I had any null characters. And no, I did not have any null characters. And then what we did was we tested the response, and we wanted to see the percentage of no responses against the percentage of yes responses. So 87.7437 were no, and 12.2563 were yes. So you wanted to see the train file after we had manipulated all that data, and you can see that it is now all numeric. And we wanted to see the test file as well. The test file is in the same format as the train file, except that it does not have a response column. The thing we did was we wanted to see the info on the train file, and you can see it's all integers and one float. We've gotten rid of all the objects. And it should be test file. I don't know what happened, but it should be test file. I don't know if it's going to work or not. Oh, it worked. Okay, so yeah, the test file is in the same format as the train file, except for the fact that there's no response. Now we set up our features, and our features are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns. And your train labels is your response column in your training file, and it's been reshaped. And the next thing we want to do is we want to define our X, Y, and X test variables. So your Y is your target variable, and it's train labels. X is train features, and X test is test features. And it's always important to check the shapes of these items to make sure that the shape of the number of columns in X is the same amount as the number of columns in X test, because that's how the model is set up. The model is set up for the same number of columns as X. And then what we do is we split our training set into train X, val X, train Y, val Y, using train test split with X, Y, a random state of 1, and a test size of 15%. And I decided not to use the standard scalar because I just felt I don't think that it was helping my results, and you'll find out at the very end. So you can see train Y, you've got lots of zeros in it, and you can see val Y, you've got lots of zeros in it. Train X is just basically the training file, but it's not as much of the training file because it's been broken down, and there's no response column. And the X file would look the same as the train X as well. So now what we do is we want to check the shape of the training and validation set. So train X and val X, you want to make sure that they've got 10 columns, and train Y and val Y, you want to make sure that they have the same amount of rows as train X and val X. So the next thing we do is we set up our sequential. So model is sequential. Input dimensions is 10, output dimensions is 1. But I ended up not using the input dimensions. And that's where I had to do a lot of work and experimentation to try to get this to work, because when I got this information out of publications, it didn't work. And I had to do a lot of research myself and trial and error to get it to work. But you can see the input was a 10 dimensions, and the first column we used ReLU. The second column was 10 dimensions with ReLU. And the third column was your output, so that's going to be 1, and it's going to be a sigmoid. Batch size was 16. We had a small batch size. and the number of epochs was 5. So I set that up for a small number of epochs, which I suppose if I wanted to, I could increase the epochs and see if I could increase my accuracy. I might do that. I might just increase the epochs to try to increase the accuracy, because it was in the middle of the night when I was working and I was really tired. But I'm not going to do it right now because it takes such a long time. And then we fit our model to train X, train Y. We had 50 epochs and checked our validation data, val X and val Y. Then we set up our value for Y pred, so that was val X, and val Y and Y pred were flattened. So then the next thing we did after we trained the data, I wanted to compare the actual values with the predicted values. And you can see the predicted values were not integers. So then we fit our model XY, and that I had 82% accuracy. But what I will do when I finish this video, I'm going to go back and see if the accuracy improves if I increase the number of epochs in the very top of this. The accuracy was 82%. Then what we did was we did our prediction on X test, and the values were really low. So what I did was I multiplied the values by 2.71828, and that is like the number E, which is like a Euler's number. It's like a transcendental number. It's sort of like pi. If you know mathematics, it's sort of like pi. And then so since the values coming out were actually numeric values, they were not integers. So I said, well, if it's less than 50%, it's 0. If it's greater than 50%, it's 1. And I experimented with that as well. Like he tried like 0.6, 0.707, 0.4. But 0.5 seemed to be the score that gave me the highest accuracy rate. And then after I did that, I had lots of zeros and a few ones. And then what I did was I set it up into a data frame. And you can see this is my data frame. And this is what I submitted to Analytics VidHaya. So what you would do is when you submit it to Analytics VidHaya, what you would do is you would take your submission CSV and you would download it. And it would come up in your download folder of your computer, and I use a Chromebook. And then what would happen is you would submit that to Analytics VidHaya, and I did submit it to Analytics VidHaya, although I can't show it to you because the screen recorder I have only records on one tab. And I got a 78%, which was 7 points lower than the highest percentage, so that wasn't too bad. So that concludes my solution to the Analytics VidHaya upsell competition being held in September 2020. Let me know your comments. Let me know what you think. If you've got any comments about how I could improve this, please let me know. And if you like the work I'm doing and you want to make a donation, I've got my email address for my PayPal account down below, because the only way that I can make any money is to actually ask for donations, because I don't have enough subscribers. And thank you so much for watching my video, and I look forward to making a new one for you.